Now we need to count on in ones. So here we start with 95. That's 9 tens and 5 ones. Then we have 96, 97, 98, 99, and then if we add one more 1, we have 100. That's because now that we've got 10 ones, we need to exchange those 10 ones for 1 10. But doing that gives us an extra 10. So we've got 10 tens altogether, and we need to exchange those for 100. So now, if we keep on adding ones, we get 101 because we've got 100 0 tens and 1 1, then 102, 103, 104. Now 634, so there's 6 hundreds, 3 tens and 4 ones. We're counting in ones, so next we have 635, 636, 637, 638, 639, and if we add one more 1, we get 640, because we can exchange our 10 ones for one more 10, meaning that we now have 4 tens and 0 ones. Then 641, 642, 643. Now we start with 805, so that's 8 hundreds and 5 ones. Next, 806, 807, 808, 809, 810, because we can exchange these 10 ones for 1 10. Then 811, 812, 813, 814. And now 296, so we have 2 hundreds, 9 tens and 6 ones. Then 297, 298, 299, and if we add one more 1, we get 300. That's because we've now got 10 ones, so we can exchange those ones for 1 extra 10, but doing that gives us 10 tens, so we need to exchange those 10 tens for an extra 100, meaning that we have 3 hundreds, no tens and no ones. So if we continue counting in ones, we get 301, 302, 303, 304, 305. We can also show counting using place value counters. So first we started with 95, so that's 9 tens and 5 ones. Then we continued adding ones. So here we have 9 tens and 9 ones, so 99. But you can see if we have one more 1, we get 100, because we can't have more than 9 in any place value. So we can't have 10 ones. We need to exchange those 10 ones for 1 10. But doing that gives us 10 tens. So we need to exchange those 10 tens for 100. Then we can continue counting in ones until we get to 104. Then we started with 634, so there's 6 hundreds, 3 tens and 4 ones. We can keep on adding ones, but when we get 10 ones, we need to exchange those for 1 10, and then we can continue adding ones until we get to 643, so 6 hundreds, 4 tens, 3 ones. Then we started with 805, so 8 hundreds, no tens and 5 ones. We can keep on adding ones, but when we get 10 ones, we need to exchange those for 1 10. And then we keep on adding ones until we end up with 814, so 8 hundreds, 1 10 and 4 ones. Now 296 means we have 2 hundreds, 9 tens and 6 ones. We can keep on adding ones, so here we've got 299, but if we add just one more 1, we get to 300. That's because we've now got 10 ones, So we need to exchange those ones for 110, and doing that means that we have 10 tens. So we exchange those 10 tens for an extra 100, which means we have 300. Then we can keep on adding ones until we get to 305. Now we need to add a single digit number to a 3-digit number, and we're going to do this on a number line using bridging. That means we're going to add however many we need to get to the next multiple of 10, so to a number that ends in a 0, then we're going to add the rest. First we have 479 plus 4. So on a number line we can start with 479, and if we add one more, that takes us to 480. So to a multiple of 10, a number that ends in a 0. But we've only added 1, and we need to add 4, so that means we need to add 3 more, and that gives us our answer 483. Now let's try 328 plus 6. If we start at 328, we can add 2 to get to 330, so get to the next multiple of 10. And then if we want to add 6, we need to add 4 more, because if we add 2 and then add 4, we've added 6 altogether. So 330 plus 4 is 334, so that's our answer. Now here, I've used a number line, but you might be able to work these questions out mentally, so without needing to use a number line, using mental methods instead. And the easiest way to do that is to think how many more to get to the next multiple of 10, so here to 330, and then how many do I need to add after that? Now we have 695 plus 9. Well, if we add 5, that will take us to 700, because we already have 9 tens in the number we start with. So we've added 5 and want to add 9 altogether, so we just need to add another 4, and that gives us 704 as our answer. And finally, we have 294 plus 8. We can start with 294, and we know that 6 more will take us to 300, because 4 and 6 make a number bond to 10, but as we already have 9 tens, our hundreds digit moves up. So we've added 6 and need to add 8, so we just need to add 2 more, so our answer is 302. So now let's take a closer look at these questions, but let's show base 10 blocks so that we can understand what's happening. First, we had 479, so there's 4 hundreds, 7 tens, and 9 ones, and we were adding 4. First, we can add 1, and that means we have 10 ones, so that gives us another 10, so takes us to 480, and then we just need to add 3 more ones, so that we've added 4 ones altogether, and that means that we have 4 hundreds, 8 tens, and 3 ones, so that's 483. Then we started with 328. If we first add 2, that gives us 330, but that's adding 2, and we need to add 6, so we need to add 4 more ones, so that we've added 6 altogether, and that means we have 3 hundreds, 3 tens, and 4 ones, so that's 334. Now we started with 695, so 6 hundreds, 9 tens, and 5 ones. If we first add 5, that gives us 10 ones, which we can exchange for 1 10, but now we've got 10 tens, so we need to exchange those for 100. So adding 5 has given us 700, but we want to add 9, so we need to add 4 more to give us 704 as our answer. And then 294, so there's 2 hundreds, 9 tens and 4 ones, and we need to add 8. If we first add 6, that takes us to 300. Because we've got 10 ones now, so we exchange those for 1 10, and doing that means we have 10 tens, so we exchange those for an extra 100. So 294 plus 6 is 300, but that's adding 6, and we want to add 8. So we need to add 2 more, so that we've added 8 altogether, and that gives us 302. Now we can also represent addition using place value counters. So here we started with 479, so that's 4 hundreds, 7 tens and 9 ones, and we need to add 4, so that's add 4 ones. We can add 1, then exchange 10 ones for 1 10, and then add 2, 3, 4, and that gives us 483 as our answer. Here we started with 328, so there's 3 hundreds, 2 tens and 8 ones. To add 6, we can first add 1, 2, exchange, then add 3, 4, 5, 6 to give us 334. Then 695 means we have 6 hundreds, 9 tens and 5 ones. We need to add 9 ones, but we can first add 1, 2, 3, 4, 5, exchange, then exchange again. Then, because we've already added 5, we need to add 4 more. So if we add another 4 ones, that gives us 704. And for 294 plus 8, we can start with 294. First of all, we can add 6 ones, then exchange, and exchange again. And then, because adding 6 ones takes us to 300, we just need to add 2 more ones, and that gives us 302. Now for these questions, we need to add a 2-digit multiple of 10 to a 3-digit multiple of 10. So remember, a multiple of 10 is a number that ends in a 0. So first, we have 140 plus 40. Now because we're adding tens, if we highlight our tens digits, we have 4 tens and we're adding 4 tens. So in our answer, we have 8 tens, but our other digits stay the same. So we still have a 1 as our hundreds digit, and we have a 0 as our ones digit. Because we start with 0 ones, we're adding 0 ones, so we have 0 ones in our answer. If we're adding 2 multiples of 10, so 2 numbers that end in a 0, our answer will be a multiple of 10 as well. So now let's try 270 plus 50. Here, if we highlight our tens digits, we have 7 tens and we're adding 5 tens. But that gives us 12 tens, and 12 is a 2-digit number. Remember, we can only have 1 digit in each place value. So that means that our hundreds digit is going to change as well. So what we can do is take our hundreds and tens together and work out 27 plus 5. That's 32. So our answer is 320, because the ones digit stays the same, so it's still 0. Now 380 plus 60. If we highlight our tens, 8 plus 6 is 14. But that's a 2-digit number, so we know that our hundreds digit is going to change as well. Now if we work out 38 plus 6, that's 44, so our answer is 440. So let's take a closer look at these questions, and show base 10 blocks so that we can see what's happening. For this first question, we started with 140, so 104 tens, and we were adding 40, so if we add 4 tens, that gives us 8 tens, we still have our 100, and we still don't have any ones. But then we had 270, so 200s and 7 tens, and we were adding 50. So if we add 5 tens, we can add 1, 2, 3, 4, 5. But here we've got 10 tens, so we can exchange those for an extra 100. So that's why we get 320 as our answer. And then we started with 380, so that's 300s and 8 tens, and we were adding 60. So we can add 6 tens. If we add 1, 2, 3, 4, 5, 6 tens, you can see that we have 14 tens, but we can regroup the 10 tens that we have here into 100. So that gives us 400s and 4 tens, or 440 as our answer. We can also show the addition using place value counters. So here we started with 140, and adding 40 means we were adding 4 tens. So that gives us 180, so 108 tens as our answer. Then we had 270, so that's 200s and 7 tens, and we were adding 50. So we need to add 5 tens. We can add 1, 2, 3, exchange, then add 4, 5 tens, and that gives us 320. And for 380, we start with 300s and 8 tens, and we need to add 6 tens. So we can add 1, 2, exchange, then add 3, 4, 5, 6, and that leaves us with 400s and 4 tens, so 440 as our answer. Now we need to count on in tens from a 3-digit number. So here we start with 157. So that's 100, 5 tens and 7 ones. Because we're counting in tens, we're adding 1 10 each time. So if we add another 10, that gives us 167, 177, 187, 197. But then if we add another 10, that gives us 207. That's because we now have 10 tens, and when we get 10 tens, we always regroup those tens into 100. So that means that we now have 200s, no tens, and 7 ones, so 207. Notice, because we're adding tens, our ones digit is staying the same, so our ones digit is always a 7. But if we ignore our ones digit, we can see that we have 15, 16, 17, 18, 19, 20. So counting on in tens from a 3-digit number is just like counting on in ones, but then with our ones digit staying the same. So now if we keep on adding tens, we get 217, 227, 237, 247. Now we start with 539, so that's 500s, 3 tens and 9 ones. We're counting in tens, so if we add a tens block each time, we have 549, 559, 569, 579, 589, 599, so that's 500s, 9 tens and 9 ones. But if we add another tens block, we get 609. That's because we now have 10 tens. So we exchange those 10 tens for 1 extra 100, And that means that we have 6 hundreds, no tens, and of course we still have 9 ones. So if we know that 1 more than 59 is 60, if we only look at the first 2 digits, we have 59 and then 60, but that means that 10 more than 599 is 609. So then we get 619, 629. We can also show the counting using place value counters. So first we started with 157, so 100, 5 tens and 7 ones. Because we're counting in tens, we can add tens counters each time. But then you can see that when we get 10 tens, when we have 10 tens counters, we need to exchange those for 1 hundreds counters. So that's why after 197, we get 207. And then we can keep on adding tens counters until we reach 247. Then we started with 539, so there's 5 hundreds, 3 tens and 9 ones. Counting in tens means that we're adding a tens counter each time. So now we have 599, but if we add another tens counter, because we have 10 tens, we need to exchange those for an extra 100. So that's why 10 more than 599 is 609, because now we have 6 hundreds and no tens, and of course we still have our 9 ones. Then we keep on adding tens counters until we get to 629. In these questions, we need to add a multiple of 10 to a 3-digit number. Remember, a multiple of 10 is a number in the 10 times table, so a number that ends in a 0. First, we have 242 plus 60. Now, because we're adding a multiple of 10, we can highlight our tens digits. We have 4 tens, and we need to add 6 tens. But 4 plus 6 is 10, and we can't write 10 in our tens place because we can only have 1 digit in each place value. So that means our hundreds digit will change as well, because remember, when we get 10 tens, we've made an extra 100. So what we can do is work out 24 plus 6. That's 30, so the digits we've highlighted will change to a 3 and a 0, and the ones digit stays the same because we're not adding any ones. So that gives us 302. 24 plus 6 is 30, and the 2 ones stays the same. Now 458 plus 70. Highlighting our tens digit, 5 plus 7 will give us 12, but that's a 2-digit number, so instead we can work out 45 plus 7. That's 52, so our answer is 528, because 45 plus 7 is 52, and the 8 ones stays the same because we're not adding any ones. Now 865 plus 80. Now 6 plus 8 is 14, but if we have 14 tens, we'll make an extra 100. So we look at our hundreds and tens digits together. 86 plus 8 is 94. So our answer is 945 because our ones digit stays the same. Finally, we have 194 plus 90. 9 plus 9 is 18. So 19 plus 9 is 28. So we change our hundreds digit to a 2 and our tens digit to an 8. The ones digit stays the same, so we get 284. Now let's take a closer look at these questions. First, we started with 242, so that's 2 hundreds, 4 tens and 2 ones. We were adding 60, so that's adding 6 tens. If we add 1, 2, 3, 4, 5, 6 tens, we now have 10 tens, and we regroup those 10 tens into one extra 100. So now we have 3 hundreds, no tens, and 2 ones. So that's why our answer is 302. And now you can see why working out 24 plus 6 and then keeping the ones digit the same gave us our answer. Then we started with 458, so there's 4 hundreds, 5 tens, and 8 ones. Adding 70 means adding 7 tens. We can add 1, 2, 3, 4, 5, 6, 7 tens, but that gives us 12 tens altogether. 5 plus 7 is 12, but if we have 12 tens, we need to take 10 of those tens and regroup them into an extra 100. So that's why our hundreds digit goes from a 4 to a 5, so our hundreds digit increases by 1 because adding our tens gave us a 2-digit answer. Now let's look at 365, so 3 hundreds, 6 tens, 5 ones, and we need to add 8 tens. We can add 1, 2, 3, 4, 5, 6, 7, 8. Now 6 plus 8 is 14, and we have 14 tens. But we can't write 14 as our tens digit because when we have 10 tens, we regroup those into an extra 100. So that's why we have 4 hundreds, 4 tens, and we still have 5 ones in our answer. And then our last question was 194 plus 90. If we add 9 tens, we can add 1, 2, 3, 4, 5, 6, 7, 8, 9 tens. And we now have 18 tens because 9 plus 9 is 18. But when we get 10 tens, again we regroup those. So that's why in our answer we have 2 hundreds and 8 tens. We can also show the addition using place value counters. So here we start with 242 and we need to add 6 tens. Doing that gives us 10 tens, but when we have 10 tens we need to regroup. So that's why in our answer we have 3 hundreds, no tens, and 2 ones. Then we started with 458 and needed to add 7 tens. Now we can add 5 tens, regroup, and then so that we've added 7, we've added 5 already, so if we add 2 more tens, that's 7 tens added altogether, and we now have 5 hundreds and 2 tens in our answer. Now we start with 365 and we need to add 8 tens. We can add 1, 2, 3, 4, then regroup, then add 5, 6, 7, 8, and that leaves us with 445. And finally, we started with 194 and we were adding 9 tens. So we can add 1 10, exchange. Then, because we've added 1 10 but need to add 9, we need to add 8 more tens, and that gives us 284 as our answer. So you can see why, because adding the tens means we'll need to exchange, because 9 plus 9 is 18, and if it's 10 or more, we need to exchange. What we do is highlight our hundreds digit as well. Then we can just take our hundreds and tens together and then leave the ones digit the same. Now let's count in hundreds from 0 to 1000. We have 100, 200, 300, 400, 500, 600, 700, 800, 900, and then if we add another 100 block, that means that we have 10 hundreds. But when we get 10 hundreds, we exchange those for 1000. So with the number 1000, we can imagine 10 100 blocks stacked on top of each other. Or if we're counting back from 1000 to 0, First, we can split or regroup our 1,000 into 10 hundreds. So then, if we take away 100 each time, we get 900, 800, 700, 600, 500, 400, 300, 200, 100, and then 0. We can also show the counting using place value counters. So if we're counting in hundreds, we're adding a 100 counter each time. But then, just like when we have 10 ones, we need to exchange those for 1 10. When we have 10 tens, we exchange those for 100. When we have 10 hundreds, we exchange those for 1,000. So when we have 10 of any place value, we always move to the place value to the left. So if we have 10 hundreds, that's the same as having 1,000. Or to count back, we can exchange our 1,000 counter for 10 hundreds, and then counting back in hundreds, we can take away 100 counter each time. Now we need to count on in hundreds. So first we start with 41, so with 4 tens and 1 1. Then, because we're adding 100 each time, we have 141, 241, 341, and then we can keep on counting in hundreds until we get to 941. So notice when we're counting in hundreds, the tens and ones digits always stay the same because we're adding 100 each time, not adding any tens or ones. So now we start with 66, so that's 6 tens and 6 ones. Then we have 166, 266, 366, and again we can keep on adding 100, so adding 100s block each time until we get to 966. Or if we use place value counters, starting with 41 means we're starting with 4 tens and 1 1, but because we're adding 100 each time, the tens and ones digits stay the same, and then we can keep on adding hundreds until we've got to 941. Or with 66, we can start with 6 tens and 6 ones, and then they always stay the same because we're only adding 100 counters. Now for these questions, we're adding 3-digit numbers, but in each question, one of the numbers is a multiple of 100, so that's a number that ends in 2 zeros, or has zeros in the tens and ones place values. First, we have 526 plus 400. So here, because we're adding hundreds and not adding any tens or ones, we can highlight our hundreds digits, and we can see that we have 500s and we're adding 400s. So in our answer, we have 900s. And then the tens and ones digit of our first number stay the same because we're not adding any tens or ones. So we get 926. Now we have 406 plus 400. Again, if we highlight our hundreds digits, 4 plus 4 is 8, but then the 0 in our tens and 6 in our ones will stay the same because we're not adding any tens or ones. We're only adding 400s. So now we have 500 plus 319. Now this time the multiple of 100 is written first. But remember, with addition, order doesn't matter, so we can do the same thing. We can highlight our hundreds digits and we can see that we have 5 plus 3. So in our answer we have 800s, but this time it's the 1 and 9, so the tens and ones digit of our second number that stay the same, because we don't have any tens in our first number, so if we add 110, that's 110 in our answer, and we don't have any ones in our first number, so if we add 9 ones, then we have 9 ones in our answer. Now 700 plus 122. Now highlighting the hundreds digits, 7 plus 1 is 8, so that's 8 hundreds in our answer, and then the 22 stays the same because we don't have any tens or ones in our first number, so we get 822. Now let's take a closer look at these questions. First, we started with 526, so that's 5 hundreds, 2 tens, and 6 ones. Adding 400 means we can add 4 hundreds blocks, and now you can see that we have 9 hundreds blocks altogether, but we still have our 2 tens and our 6 ones, so those digits are the same as in the number that we started with. Then we had 406, so that's 4 hundreds, no tens, and 6 ones. And if we add 4 hundreds, we now have 8 hundreds altogether, but we still have no tens, and we still have 6 ones. Then we started with our multiple of 100, so started with 500. We were adding 319, so that's adding 3 hundreds, 110, and 9 ones. You can see that altogether we now have 8 hundreds, but because there weren't any tens or ones in the number that we started with, the tens and ones that we added appear exactly as they are in our answer. So 110 and 9 ones because we didn't start with any tens or ones. Then we had 700 plus 122, so that's adding 100, 2 tens, and 2 ones. Again, you can see that we have 8 hundreds altogether, and we still have the 2 tens and 2 ones that we added in our answer because we didn't start with any tens or ones. We could also show the addition using place value counters. So for this first question, we just add 4 hundreds counters to leave us with 9 as our hundreds digit, and the tens and ones have stayed the same. Then from 406, adding 400 just means adding 4 hundred counters, and that means that we have 800 counters now, but we still don't have any tens counters, and we still have 6 ones counters. That's because we were only adding hundreds. Then we started with 500 and added 319. So we can add 3 hundreds, 110, and 9 ones to give us 819, so 8 hundreds, 110, and 9 ones as our answer. Notice we get the same answer even if we were to start with 319, so start with 3 hundreds, 110, and 9 ones, and then add 5 hundreds. If we add 1, 2, 3, 4, 5 hundreds, you can see that what we get is exactly the same. We still get 8 hundreds, 110, and 9 ones. So that's what we mean when we say that with addition, order doesn't matter. We get the same answer no matter what order we add the numbers in. And then we had 700 plus 122. So we were adding 100, 2 tens, and 2 ones. So that gave us 822 as our answer. But again, we can see that we would have got the same answer if we'd started with 122 and then added 700. Because if we add 7 hundreds counters, you can see that what we end up with is exactly the same. That's 8 hundreds counters, 2 tens counters, and 2 ones. Now we need to add using column addition. First, we have 552 plus 38. So we set the question out like this. with our digits lined up on the right hand side. Because remember, we count place values from the right, so if we've lined the digits up on the right, then our ones, tens and hundreds columns will be lined up as well. Now with column addition, we work from right to left, so we start by adding our smallest place value column, so with our ones. We have 2 plus 8. That makes 10, but we can't write 10 because we can only have one digit in each place value, so one digit in each square. So we need to write 10 as 10. So with the first digit of the number above the next place value column along, so here above our tens column. So now, because we've added our ones, we move on to our tens column. We have 1 plus 5 plus 3. That makes 9. And now we move on to our hundreds, and we have 5 plus nothing, so we have 5. That gives us an answer of 590. So now let's try 679 plus 43. Again, we've got the question written out with the digits lined up on the right hand side. So with the 3 ones in 43 underneath the 9 ones in 679, and then with the 4 tens in 43 underneath the 7 tens in 679. So now we can start by adding our ones digits. 9 plus 3 is 12, but that's a 2-digit number. So we need to write the first digit above the next place value column along. 9 plus 3 is 12, so that's 1, 2. Now 1 plus 7 plus 4 is 12, so again that's 1, 2, with the first digit written above the next place value column along, so here in our hundreds place value column. And now we have 1 plus 6 plus nothing, so that's 7, and that gives us 722. Now 464 plus 152. We start with our ones column. 4 plus 2 is 6. We don't need to write anything above because 6 is a single digit or one-digit number. So we can move on to the tens. We have 6 plus 5, and that's 11. So we write 11 as 1, 1, because it's a 2-digit number, so first digit above the next column along. Finally, we can move on to our hundreds column, and 1 plus 4 plus 1 is 6, so our answer is 616. Finally, we get to 388 plus 219. 8 plus 9 is 17, so that's 17. 1 plus 8 plus 1 is 10, so that's 10. And 1 plus 3 plus 2 is 6, so our answer is 607. Now let's take a closer look at these questions, so we can show base 10 blocks to help us understand why this method works. So why, if we get a 2-digit answer when we add a column, we write the first digit above the next place value column along. Here we start with 552, so that's 5 hundreds, 5 tens and 2 ones. We started by adding 8 ones. So if we add 8 ones, that gives us 10 ones altogether. But because we only have one digit in each place value, we exchange those 10 ones for 1 10, so we can put this above our tens column. So notice here, we've made one extra 10, so that's why we write the 1 above our tens column. And now, because we exchanged, we don't have any ones, so that's why we have a 0 as the ones digit of our answer. So now we have 1 plus 5, the 1 that we made from adding our ones, and the 5 tens that we started with. We need to add 3 tens. When we do that, that gives us 9 tens altogether. And we're not adding any hundreds, so we still have 500s, so that's why we get 590. Then we started with 679, so that's 600s, 7 10s and 9 1s. We were adding 43, so first we can add 3 1s. Doing that gives us 12 1s, but we can regroup 10 of these ones into one 10, so let's put that above our tens blocks. Notice we have one 10 that we've made, and we have 2 1s left over. So 9 plus 3 is 12, but we write the first digit above the next place value column along because we can exchange it. So now we have 1 plus 7, that's the 1 that we made from adding our 1s, and the 7 that we started with, and we need to add 4 more 10s. If we add 4 10s, we now have 12 10s altogether. But we can regroup 10 of those 10s to make an extra 100, so let's move that above our hundreds blocks. Notice here we've made one extra 100, so that's why we write a 1 in our hundreds column, and we have 2 10s left over, so that's why we write 2 as the tens digit of our answer. Now we're not adding any hundreds, so we have the 100 that we've made and the 600s that we started with, so that's 700s. Then we started with 464, and we were adding 152. We can add 2 1s to give us 6 1s. Then we need to add 5 10s. But when we do that, we get 11 10s, and we can regroup 10 of those 10s to make an extra 100. So we can move this block above our other hundreds blocks, and then we can write 1 above the hundreds digits in our question, and because we now have 1 10, we can write 1 as the tens digit of our answer. So 6 plus 5 is 11, but 11 10s is the same as 100 and 110, so that's why we write 1 above our hundreds digits. So now we've made 1 extra 100 by adding our 10s. We have 4 hundreds in the number that we started with, and we need to add 1 more 100, so that gives us 6 hundreds altogether. And then for our last question, we started with 388, so 300s, 8 10s, 8 1s, and we were adding 219. We start by adding 9 1s, and that gives us 17 1s. But we don't write 17 in our answer, because we can exchange 10 of those 1s for 1 10. So we've made 1 extra 10, and now, because we exchanged, we only have 7 1s, so that's 7 as the ones digit of our answer. So now we've made an extra 10, we had 8 10s in the number that we started with, and if we add 1 more 10, that gives us 10 10s. But 10 10s is the same as 100, so we can write 1 in our hundreds column, and because we now don't have any 10s, we need to write 0 as the tens digit of our answer. So now we've made 100 by adding our 10s. We had 300s to start with, so if we add 2 more hundreds, that gives us 600s altogether. So here we've shown addition using base 10 blocks, but we could also use place value counters. So for our first question, we started with 552 and were adding 38. First we added 8 1s, but that gave us 10 1s, so we could exchange those for 1 10, leaving us with 0 as the ones digit of our answer. Then we need to add 3 10s, and that gives us 9 10s altogether now, and we still have our 500s. Then we started with 679. We were adding 43. We can add 1, 2, 3 1s. That meant that we've made 1 10 and we have 2 as the ones digit of our answer. Then we need to add 4 tens. We can add 1, 2, exchange, then add 3, 4. And now, because we've made this extra 100 by adding our tens, we have 7 hundreds. Then 464, so 4 hundreds, 6 tens, 4 ones. We can add 2 ones to give us 6 as our ones digit. Then we need to add 5 tens. We can add 1, 2, 3, 4, exchange, and then add our 5th 10. That leaves us with 1 as the tens digit of our answer. So because we've made this extra 100 by adding our tens, and we started with 4 hundreds, we just need to add 1 more 100 to give us 6 as our hundreds digit. And then we started with 388. To add 219, first we add 9 ones. We can add 1, 2, exchange, then add 3, 4, 5, 6, 7, 8, 9, and that gives us 7 ones. Then we need to add 1 10, but now we've got 10 tens altogether, so we exchange. Then we add 2 hundreds, and that gives us 6 as our hundreds digit.